Welcome back to the deep dive. You've definitely given us a lot to work with this time, a real mix of sources covering everything from high-level ICT strategy down to the real nuts and bolts of development and talking to stakeholders.
Yeah, it's quite a stack. Thanks for sending it all over. It really paints a picture, doesn't it? The core theme that jumps out is, well, how to actually strategize and then implement ICT solutions effectively.
Exactly. So our mission today is to boil all that down. We want to pull out the key insights, the stuff you really need to know to get up to speed on this quickly.
Right. We're aiming to give you that streamlined understanding how organizations can, take these tech ideas from just a concept right through to making them happen.
So here's the plan for this deep dive. We'll kick things off with gap analysis. Think of it like a tech health check for your organization. Where are you now versus where you want to be?
The starting point.
Then we'll dive into models.
Mm-hmm.
How visualizing things, maybe with diagrams, helps map out the path forward. After that, actually creating an action plan.
The practical steps.
Yep. And then the SRS, the software requirements specification. That sounds technical, but it's basically the detailed instruction manual for any software project. Super important.
Controversial, yeah.
We'll also cover what actually happens during implementation and why documentation matters so much.
Yeah.
And finally, because tech doesn't happen in a bubble, we need to talk about engaging stakeholders, keeping everyone on board.
And you'll see how it all links together. It's not just separate steps, but a whole interconnected process. We want to give you a kind of framework for thinking about this stuff.
Perfect. We're aiming for those aha moments, keeping it clear, respecting your time, but giving you that solid knowledge base. All right, let's get started.
Okay.
So first up, gap analysis. This came up a lot in the sources, especially that strategizing ICT solutions. One, it sounds simple enough, find the gap. But what's the real value here?
Well, at its heart, it is about finding those differences, those discrepancies between where an organization is with its tech right now, its current state, and where it wants to be, the desired future state.
Yeah.
But it's more than just finding problems. Think of it like maybe an annual physical for your tech. It helps spot not just the obvious issues, but maybe the underlying things that could cause bigger problems down the line.
I like that analogy. So it means really looking honestly at what you have now. Network speed, system reliability, security holes, maybe even how easy the current tools are for staff to use.
Exactly. That's the current state, a really clear snapshot of today. And the desired state, where you want to get to, well, that's not just desk work. It's shaped by some key things mentioned in your sources.
Like what?
Like the big picture strategic goals of the business, understanding where the organization wants to go long term and how tech can actually help get it there. That's fundamental.
Right. So technology isn't just its own thing. It has to support the main business strategy.
Absolutely. And it's not just internal focus either. The sources stress looking outside too, researching what's normal in your industry, maybe even global standards, setting realistic benchmarks.
Okay, so comparing yourself to others, best practices.
Yeah, what are competitors doing? And critically, what do stakeholders need? That briefing document mentioned customer needs specifically, and you can't forget compliance.
Rules and regulations.
Definitely. That healthcare data protection example in one of the PDFs, it shows how laws can heavily influence what that desired state has to look like. You also need to think about barriers, like budget limits or resistance to change, and plan for them.
Makes sense. So current state, desired state, identify the differences, that's the gap identification.
Yeah.
And then you write it all up in a gap analysis report.
Pretty much. That report lays it all out. Where you are, where you want to be, what the gaps are, and maybe some early ideas for solutions. It becomes a kind of roadmap.
And the benefits. The sources listed quite a few.
Yeah, big ones. It shines a light on weaknesses, makes sure tech plans actually support the business goals, gives you a solid basis for making decisions, helps you plan better. Plus, it can boost efficiency and accountability by setting clear targets.
But it's not perfect, right? There are limitations mentioned too.
True. The whole thing depends on having accurate data to start with. That can be tricky. And it can definitely take time and resources, especially for complex stuff. You might also hit resistance from people who like things the way they are. And you have to be careful with the scope. If you look too narrowly, you might miss important gaps elsewhere.
Good point about scope. And when digging into that current state, the materials gave concrete examples, like network gear routers, switches, system speed lag, downtime, security vulnerabilities, even how usable the systems are for employees.
Those are all tangible things you can assess. And shaping the desired state really comes down to those key drivers, aligning with strategy, meeting compliance rules, and crucially, working within your budget and resource constraints. You might want the absolute best, but what's realistic? Maybe it means phasing things in.
Okay, that gives us a solid handle on gap analysis. We know where we are, where we want to go. But how do we actually map out the path? That brings us to models, doesn't it?
Exactly. Moving from analysis to planning, models are incredibly useful. The materials on model development really highlight this. They're basically simplified pictures of systems that can be pretty complex. Visual shortcuts, if you like.
More than just pictures, though. The briefing doc said they help with understanding, communication, problem solving, even documentation. Sounds quite versatile.
Very much so. And one specific type of model that Module 10 goes into detail on is the data flow diagram, or DFD. These are great for showing how information moves around.
Okay, DFDs. Break that down for us. What's the main idea?
Imagine data flowing through your system, like water through pipes. A DFD is a visual map showing where the data comes from, where it goes, what happens to it along the way, how it gets processed, and where it ends up.
So like a flowchart for data.
Sort of, yeah, but specifically focused on data movement. The cool thing is, a good DFD can reveal potential bottlenecks or weird data paths before you even start building anything. It makes abstract processes visible for everyone, techies and non-techies alike.
That common understanding sounds key. Now, the materials differentiated between logical and physical DFDs. What's the difference there?
Think of it like this. A logical DFD is about the what processes happen, what data moves between them. It ignores the specific technology. It's a conceptual plan used early on.
Yeah.
A physical DFD is the how. How is it actually implemented? Which database stores this data? Which specific program performs that calculation? Who does what? It's closer to the actual build.
Ah, okay. Logical is the recipe, physical is the kitchen setup and specific tools you use.
That's a great analogy. Perfect. And making these DFDs has real plus points. They make complex things easier to understand visually. They give teams a common language to talk about the system, and they can help spot problems early, like data jams or security risks.
So you can catch issues before they become big headaches. Makes sense. What are the symbols used? Are they standard?
Well, there are a few common styles or notations like Yerdon-encode, GAIN, and Sarsen. They use slightly different shapes for things, but the core concepts are the same. The main thing is to be consistent within your project. GAIN and Sarsen is often seen in business contexts.
Okay. And what are the essential parts, the building blocks of any DFD?
You've basically got four main things. First, processes. These are the activities that transform data. They take input, do something, and produce output. Think calculate tax, validate order, generate report, the verbs.
Got it. Processes are the actions. What's next?
Second, data stores. These are where data sits, like databases or files, examples, customer records, product inventory, order history, the nouns, kind of.
Okay, places data rests.
Third, external entities. These are things outside the system that interact with it sending data in or getting data out, like a customer, a supplier, another system, or maybe a manager.
People or systems outside the main box. And
Okay.
The last one connects them all.
Exactly. Fourth is data flows. These are the arrows showing data moving between processes, data stores, and external entities. They show the actual paths information takes.
Right. Now, these DFDs often have different levels, like zooming in.
Spot on. You start broad and get more detailed. The context diagram, or level 0, is the highest view. The whole system is just one bubble, showing how it connects to those external entities, like online shop interacting with customer and payment system.
The big picture. Then level 1.
Level 1 breaks that main bubble down. You see the major sub-processes inside the system and how they connect, maybe introducing the main data stores they use. So online shop might break into search products, manage cart, process payment.
Okay, starting to see the inner workings, and level 2 goes deeper still.
Yep. Level 2 decomposes those level 1 processes further. Process payment might break down into verify card, charge amounts, send confirmation. You see more detail, maybe more specific data stores.
And you could keep going. Level 3, 4. Level N.
You could. Those get really granular, almost down to code level. But often, level 1 or 2 gives enough detail for most planning and communication. You don't always need to go super deep.
So if someone wants to create a DFD, what are the basic steps?
First, define the scope clearly. What's in, what's out. Then, list the external entities, who or what interacts with it. Next, identify the main processes inside. Then, figure out the data stores. Where does data live? After that, Map the data flows, draw the arrows showing data movement. Then actually assemble the diagram using your chosen symbols and labels. Finally, and this is key, validate it. Does it make sense? Do the rules checkout, like data flows need a start and end, processes need inputs, outputs, data stores connect to processes, not directly to outsiders.
Okay, that's a great overview of DFTs and modeling. So we've analyzed the gaps, visualized the path. Now we need to plan the actual doing, right? Let's talk about the action plan.
Absolutely. That's the crucial next step. Module 3 in your sources really digs into this. Once you know the gaps and have maybe modeled the target, you need that detailed roadmap, the action plan to get there. And a huge part of that is creating a detailed schedule.
Yeah, the material called it like putting together a puzzle. Sounds like it needs careful thought. What goes into building that schedule?
First off, you need to identify all the tasks. Break the whole project down into smaller chunks. If you're rolling out new software, tasks might be things like gathering requirements, picking the software, installing it, moving data over, training people, then actually going live.
Okay, break it down. Then what?
Then you figure out the sequence. Which tasks depend on others? You can't train users before the software's installed, right? Tools like Gantt charts or flow charts really help visualize this order and the dependencies.
Right, dependencies are key.
Definitely. Next, assign responsibilities. Who owns each task? Make sure they have the skills and resources. Then estimate how long each task will take. Be realistic here, build in some wiggle room, maybe. With durations estimated, you set start and end dates, keeping those dependencies in mind. It's also super helpful to identify key milestones along the way. Big checkpoints like research complete or software installed.
Like signposts on the journey.
Exactly. And you absolutely have to consider constraints and risks. What could go wrong? Budget cuts, key person leaves, build in contingency time or backup plans. And importantly, this isn't a solo job. Get feedback, collaborate with the team to make sure the schedule is workable.
Good point. It needs buy-in.
And finally, remember, it's not set in stone. You have to monitor progress and adjust as you go. Things always change.
Now, the sources really stress that training, communication, and policy stuff aren't extras. They have to be part of this schedule.
Yeah.
Why is that integration so vital?
That's a really critical insight. Take training. You need to figure out who needs training on what, develop the actual training plan, the content, the schedule, who delivers it, and then slot that training into the main project schedule at the right time. Like, train people just before they need to use the new system, not months before or after.
So timely training. What about communication and policies?
Communication is similar. You need a plan. Who needs to know what, when, and how? Keeping everyone informed manages expectations and avoids nasty surprises. And policy development often goes hand in hand with ICT changes. New security tool. You probably need to update your security policy. That policy work needs to happen alongside the tech rollout, not as an afterthought.
So the schedule coordinates the tech and the people and the rules. The materials also mentioned setting standards and targets in the action plan. How does that help?
Clear standards and targets make success measurable. A standard defines the minimum acceptable level, say, internet speed must be at least 50 Mbps. A target makes it specific and time-bound, achieve 50 Mbps in all offices within 3 months. The action plan then details how you'll hit that target, maybe assessing current speeds, upgrading lines, monitoring performance.
Okay, measurable goals. So you've got this brilliant detailed plan. How do you get the bosses, the decision makers, to say yes and give you the resources?
Yes. Getting approval. Module 3, Topic 3 covers this. It's all about understanding your audience. Know who you're talking to, what are their priorities, what are they worried about. Frame your plan to address their interests and show how it helps the organization.
Tailor the message. What about the actual presentation?
Good presentation skills are key. Structure it logically. Here's the problem, here's our proposed solution, here's the plan to get there, and here are the benefits we expect. Use visual aids, charts, timelines to make it clear, and crucially, back it up with evidence. Data from your gap analysis, maybe examples of similar successes, projected ROI. Don't just state opinions.
Make a solid case.
Yeah.
And how you deliver it matters too.
Absolutely. Communicate confidently. Practice if you're presenting verbally. Make sure written proposals are polished and easy to read. Be ready for questions. Invite them even. And this is important. Learn to handle feedback constructively. They might have valid points. Be open to discussion. Be willing to tweak the plan. Showing you can collaborate goes a long way towards getting that yes.
Okay, plan approved. Now, let's say the plan involves building new software. The sources put a huge emphasis on the software requirement specification, the SRS. What is that exactly?
Right, the SRS. Think of it as the master blueprint for the software. Module 4 really dives into this. It's a formal document that spells out everything the software needs to do. Its functions, features, capabilities, how it interacts with other things, performance levels, any constraints. It's like a contract between the developers and the client or users.
A detailed contract, so it sets clear expectations before coding starts. When does it get created?
Exactly. It's done right at the beginning, after the initial idea is fleshed out, but before detailed design and coding kick off. The goal is to get everyone, developers, clients, users, to agree on this detailed picture of what's being built.
And the payoff for doing this, it sounds like a lot of work up front.
The benefits are huge, really. It provides clarity, avoids misunderstandings later, it guides the developers, it forms the basis for agreement, defining the scope. It can actually reduce development time overall by preventing confusion and rework. It helps prevent scope creep, that thing where features keep getting added endlessly. It makes testing easier because you know what you're testing against. And it boosts collaboration by giving everyone a shared reference point.
Those are strong arguments. Any downsides or challenges?
Well, yes. Creating a good SRS can be time-consuming. It takes effort to get all those requirements right, and once it's done, it can sometimes feel a bit rigid if requirements genuinely need to change later. Plus, writing a good SRS requires specific skills, knowing how to ask the right questions, how to document clearly. That expertise isn't always easy to find.
Okay. The materials also mention product scope within the SRS. Why is defining scope so important?
Defining the product scope is fundamental. It draws the boundaries. What will this software do? Equally important, what won't it do? Which features are in? What are the limits? This clarity manages expectations, keeps the development team focused, helps control changes, and ensures the final product actually meets the business need. As the source noted, thinking about long-term value is part of defining that scope wisely.
Right, drawing the line. Now, what kinds of requirements actually go into the SRS? We mentioned functional and non-functional.
That's the core distinction. Functional requirements are the what. What actions must the system perform? The sources gave examples like user must be able to sign up, system must verify email addresses. They're the specific tasks the software executes. User stories, by the way, are a great way to figure out these functional needs from a user's viewpoint.
Okay, the what and non-functional is a
Yeah,
lot.
the how well. Non-functional requirements define the qualities and constraints. How fast should it be? How secure? How easy to use? How reliable? How many users should it handle? So user can log in is functional. User login must take less than 2 seconds is non-functional. It's about performance.
Got it. Clear difference. The sources also listed external interface requirements. What falls into that?
That covers how the software talks to the outside world, user interfaces, how people interact with it, screens, buttons, menus, hardware interfaces, any specific hardware it needs to work with. Software interfaces, how it connects to other software like APIs or databases, and communication interfaces, things like email protocols or network connections it uses.
Basically all its connection points. Now, those non-functional requirements NFR seem like a broad category. Let's touch on some key ones. Security is obviously huge.
Absolutely critical. Security requirements, as Module 5 highlights, are about protecting the system and its data confidentiality, integrity, availability. How do users log in securely? How is data encrypted? How does it defend against attacks? And availability is part of this, making sure the system is up and running when needed. Defining these in the SRS is essential guidance for building and testing a secure system. It's non-negotiable these days.
Definitely. What about capacity?
Capacity is about handling the workload. How much data can it store? How many transactions can it process per second, especially during peak times? Like, for cloud storage, what's the storage limit per user? Defining capacity helps plan the infrastructure needed so it doesn't fall over when usage grows.
And compatibility. Seems straightforward.
Mostly, yeah. It's about playing nicely with others. Does it work on Windows, Mac? Which web browsers? Does it need to integrate with specific other software? Work on certain mobile devices? Can it handle different data formats? All those interaction points need to be defined.
Then there's reliability. We want dependable software.
For sure. Reliability is about functioning correctly and consistently over time. Key aspects are availability, uptime percentage, fault tolerance, can it handle parts failing, recoverability, how quickly can it bounce back after a crash, consistency, does it give the same right answer every time, and also maintainability, how easy is it to fix. Crucial for systems where failure has big consequences, like banking.
And scalability, that's about handling growth.
Exactly. Can the system grow to handle more users, more data, more transactions without performance tanking? You can scale vertically, beefing up a single server, or horizontally adding more servers. Techniques like load balancing and microservices help achieve this. Think social media platforms needing to handle huge spikes. That's scalability.
Maintainability came up under reliability, too.
Yes, it's related, but the focus here is specifically on how easy it is to change the software later, fix bugs, add features, adapt it. Good maintainability depends on things like clean code, modular design, good documentation, and solid testing. It lowers the long-term cost of owning the software.
And usability, making it easy for people.
Crucial. Usability is about how easy the software is to learn, use efficiently, and whether users find it satisfactory. Key aspects are learnability, efficiency, memorability, can remember how to use it after a break, error prevention, recovery, and overall user satisfaction. Good usability drives adoption and productivity.
Wow, okay. And the list went on: legal, regulatory, ethical, contractual compliance, even SEO for websites.
Yeah, depending on the context, those can be vital NFRs. Compliance with laws and regulations is often mandatory. Ethical considerations are increasingly important. Contractual obligations like SLAs need to be met. And for web stuff, SEO is often a key requirement for visibility.
Plus others like performance, availability again, disaster recovery, fault tolerance again, portability, internationalization. It's a lot to consider beyond just making it work.
It really is. All these non-functional aspects determine the true quality and success of the software in the real world.
Okay, so we've painstakingly defined the requirements in the SRS. What happens next? Modules 11 and 6 seem to guide us through implementation and beyond.
That's right. The SRS is the blueprint. Now comes the building and rollout. The implementation phase is where the coding happens, databases get set up, components get integrated. You should be doing testing as you go here, unit testing individual pieces.
Build and test, build and test.
Pretty much. Then comes the more formal testing phase. This includes integration testing, do the pieces work together, system testing, does the whole thing meet requirements, and finally acceptance testing, do the users or clients accept it?
Okay, rigorous testing. Then deployment.
Yep, the deployment phase. This involves final checks, maybe migrating data from old systems, then the actual go live, making it available, and crucially monitoring it closely right after launch.
And it doesn't stop there, right? There's maintenance.
Always. The maintenance phase is ongoing. Fixing bugs, adding updates or new features based on feedback, keeping it running smoothly, adapting it as things change.
During that core implementation phase, the sources mention some key practices for success.
Oh yeah, absolutely. Things like using version control systems like Git, it's like a time machine for your code, indispensable. Using collaboration tools, Slack, Jira, things like that to keep the team communicating and organized. Automation is huge. Automated testing, builds, deployment saves tons of time and reduces errors. Good documentation during implementation, code comments, design notes is vital for maintainability later. Understanding the business context helps developers make better decisions. And don't underestimate soft skills, communication, problem solving, teamwork. They're critical.
The business impact during implementation also came up, specifically around security protocols. Why focus on security during the build?
Implementing security protocols rigorously during implementation is essential. It's about minimizing risk to the business while you're changing things. It's about compliance you need to meet those regulations from day one. It protects stakeholder confidence. Good security planning can actually manage costs by preventing breaches later. It ensures security is aligned with business goals, not hindering them. And you need training and awareness so staff don't accidentally create vulnerabilities with the new system.
So a solid implementation plan is needed. What are the key parts of that plan, according to the materials?
Module 6 laid it out well. You need a clear scope definition for the implementation itself, a detailed timeline with tasks, milestones, dependencies, careful resource allocation people, money, equipment, a plan for training programs, and a thorough outline of cost considerations, initial costs, ongoing costs, contingency funds. It's the practical guide for getting it done.
And risk management is a big part of that implementation plan.
Huge. You need to actively manage risks during implementation. That means identifying potential risks, technical glitches, resource shortages, delays, analyzing them, how likely, how bad, prioritizing them, focus on the big ones. Developing mitigation strategies, what will you do about them? Assigning responsibility for managing each risk. Integrating risk management into the main plan. Communicating about risks with stakeholders. Monitoring risks constantly, ensuring compliance. Documenting everything. Providing training. Considering external risks. Using tools. Having procedures for closing risks when they pass. And assessing how well your risk management is actually working.
Okay, implementation complete, risks managed. We talked about the SRS, but documentation doesn't stop there, does it? System documentation after launch.
Not at all. System documentation, as Module 7 points out, is vital long after launch. It's the ongoing blueprint and user guide, essential for developers doing updates, for support teams troubleshooting, and for users trying to figure things out.
What kinds of documentation are we talking about here?
Several types. Technical documentation, for developers, covering architecture, code details, APIs, user documentation, manuals, guides, tutorials for the end users, system architecture documentation, high-level overview, quality assurance documentation, test plans, results, and operational documentation, guides for running and maintaining the system day to day.
Different docs for different folks. What influences how much documentation you need?
Several things. Project complexity, more complex, needs more docs. Team size and expertise, any regulatory requirements, stakeholder needs, what do they expect, and resource availability documentation takes time and effort.
So tailor the documentation effort. How do you actually do documentation well?
It requires planning, clear standards and guidelines for consistency. Using collaboration tools like wikis helps. Having review cycles keeps it accurate and up to date. Getting feedback improves it. And document control ensures everyone uses the right version.
The materials even broke down documentation by SDLC phase. That sounds super practical.
Yeah, very useful. Requirements phase, SRS, use cases, design, architecture docs, interface specs, implementation, source code comments, technical specs, testing, test plans, cases, reports, deployment plan, user guides, release notes, maintenance, ops guides, change logs, SLAs, and review feedback, post-implementation reviews, user surveys.
That really drives home how documentation is woven through the whole lifecycle. Now, shifting gears slightly, we focused a lot on the tech and process, but Module 9 was all about stakeholder engagement. Why is that so critical?
Because ultimately, ICT projects are for people or impact people. Stakeholders are anyone with an interest, the project team, managers, customers, suppliers, users. Understanding their needs, managing their expectations, getting their input, it's fundamental to project success. If stakeholders aren't on board, even the best tech can fail.
So how do you effectively engage them? What are the key steps?
First, identify who they are. Then, understand their needs and expectations, talk to them, survey them, set up regular communication, have a plan, use the right channels, actively seek and use their feedback, make it a two-way street. Always maintain professionalism and respect. Be prepared to resolve conflicts, facilitate discussions if needed, and periodically evaluate how well your engagement is working.
It sounds like ongoing relationship management almost. What are some common roadblocks here and how do you get past them?
Good question. Misaligned expectations are common. Solution: clear, consistent communication from the start, regular check-ins, maybe shared documents. Resistance to change is another big one. Try to understand why they're resistant, offer support and training, clearly show the benefits. Sometimes you get over or under communication. Tailor your approach, ask people how they prefer to be kept informed, and conflicting interests happen. That requires careful facilitation, negotiation, looking for win-win solutions where possible.
Okay. The materials also specifically emphasized verbal communication skills for IT meetings with stakeholders. What skills are key there?
Oh, definitely. Facilitating meetings well is huge, setting agendas, keeping discussion focused, encouraging participation, managing time, resolving conflicts, summarizing actions clearly. Then there's explaining technical stuff, effectively knowing your audience, avoiding jargon, using analogies, visual aids, checking for understanding. The ability to ask good questions is vital. Open questions, probing questions, clarifying questions to uncover needs, explore options, test assumptions. Active listening is perhaps the most important, really hearing what's being said and unsaid, showing empathy, confirming understanding, and finally, clarifying, making sure everyone is on the same page, restating things, asking confirming questions to avoid misunderstandings down the line.
This has been incredibly thorough, covering the whole journey from strategy to stakeholders. As we wrap up, what's the main thread connecting all these pieces?
The biggest takeaway is just how interconnected everything is. That briefing document really nailed it. Strategic alignment, gap analysis, modeling, stakeholder engagement, careful planning with the SRS, implementation, documentation. None of these happen in isolation. They all build on each other. Understanding this whole life cycle, how the parts fit together, is absolutely fundamental if you want to successfully plan and deliver ICT solutions that actually make a difference.
So it's not just about being good at one part, but seeing the whole picture.
Exactly. And when you understand that whole life cycle, you can move beyond just doing tech projects to strategically using technology to create real, lasting value and drive innovation for the organization.
That's a great final thought. How can understanding this entire life cycle empower our listeners to use technology more strategically for lasting value and innovation? Something definitely worth pondering.
Indeed. Maybe think about which of these areas we discussed: gap analysis, DFDs, action plans, requirements, implementation, documentation, stakeholders resonates most with what you're doing now or the challenges you face. That could be a good place to dig deeper.
Well, that brings us to the end of this deep dive. A huge thank you for joining us as we unpacked all this material on strategizing and implementing ICT solutions. We hope it's given you a valuable shortcut to understanding the key concepts and maybe sparked a few insights.
Yeah, we hope so too. Take some time to reflect on how these ideas might apply in your world. Maybe revisit some of the source materials or explore related topics that caught your interest.
Because ultimately, getting a good grip on these foundational concepts is key to navigating the complex and ever-changing world of ICT. Until next time, thanks for listening.